Okay, well, let's go ahead and begin with Unit 1. Notes. I went ahead and changed the calendar dates for the new due dates. Pretty much just said that everything could be turned in on the 4th of September, which is a Friday, just to give people some time. I know some of us left out of town and may not get back until Sunday. If that's the case, I don't want to have something due on Monday that was due previous week. Other things that were already on the calendar, I think I kind of left those the same. I might have changed maybe one day just to kind of help ease something. But I just want to make sure that we know that we're on Unit 1 notes, and they're not even due till September the 11th. But you need to get the notes done before then because you have a quiz and a test. Your test is on September the 11th. So here's what I would do. If I had you in class, I would make sure that I remind everyone to put their name on their paper. First thing. I also love it if you would put like Monday and Wednesday or Tuesday and Thursday at whatever time you are. That would be helpful. The next thing that I like to do on my notes is I like to go ahead and make sure on the top of the notes, before we even start the unit, not only have I shown you the calendar and you know when the dates are coming, but I like to write it on here. So for us, quiz is on 9/9. If you are a Monday, Wednesday person. If you are a Tuesday, Thursday person, then your quiz, I'm going to go ahead and put Monday/Wednesday in parentheses, quiz, and I can do that in a different color, just so that way we're all on the same track. I'm going to put quiz 9/10 if you're a Tuesday/Thursday student, and test on 9/11. And that is going to be for Monday/Wednesday. And I'm going to put right here, and Tuesday/Thursday. Okay? So everyone's taking the test at the same time during your class period time. Okay? The only thing that will not be open or available early would be the Blackboard test or the Blackboard quiz. Everything else should be up early. I'm videoing this right now on a Friday. Hopefully I have it up to you by Saturday. Everything should be open by then for the following week. The CK12 should be open by Sunday as well. Everything. I try to open up everything on Sunday for the beginning of that week. Okay. So we also have homework number 1. If you are either Monday, Wednesday, or Tuesday, Thursday, the homework 1 is due on 9/2 at 12 p.m. There's an accuracy precision video. A lot of people get those two words confused and mixed up, and I'm actually looking at the calendar itself right here. Homework number 2. Homework 2 is due on 9/3, whether you're a Monday, Wednesday, or Tuesday, Thursday person. And then we have the CK12 reading/quiz. Again, you've already had the CK12 once. Please make sure that when you submit it and finish, then there's another button that comes up that says turn in. You have to click that turn in button also. That's when it turns it into me. If not, then I don't see it completed, and I'm thinking that you never did it. Okay? So make sure you get that done, but you get it done before 9/4 by 12 p.m. Click the turn in button before then. If not, then it's going to be late. Okay? Minus 20 points if it's late. What is the only thing that will not be accepted late is homeworks, remember? And tests are going to be given during that time unless you have a school function activity to do. Okay? The next thing, we have our notes right here. They look like this. Some of us are having some problems. On our problem, and I like having the beginning of the school year a lot of assignments for you to turn in on Blackboard to give you practice. But look at this. Page 1, page 2, page 3, page 4, page 5. Do you see that? Now, again, it depends on if you have a scanner at home or if, you, like me, I'm going to take a picture. Okay? So when I take a picture, I snap a picture, email it to myself. Then I open that email and I open a Word document on the side. I get this picture, I copy it, and I put it onto a Word document. I hit enter to the next page. I zoom this in bigger, and then I copy the second page onto the Word document. Then I copy the third page, and I continue until I'm finished with everything. I save it as one document, and then I submit it and upload it onto Blackboard. That's how you're able to get one assignment on Blackboard. Because if not, you're going to submit one page, but that's all you're going to submit. Some of us were confused and were lost, and you didn't get to submit the other pages. So we need to practice figuring out how to do one submission onto Blackboard. And I want you to practice here because I know some of the professors are not going to be as lenient. So let's practice now with my class. Now, the next thing that we have to do is let's go ahead and go over the notes. I think I've already talked about a few things already. Again, watching these notes, going through them is going to be helpful for you prior to your quiz and test. You're always welcome to go back and rewind it, rewatch it, pause it. Here's one thing that I have here on my counter. I have different pens because I like to do them in different colors, but I have some little tabs here. As a suggestion, you don't have to. You might want to tab a section that you're kind of confused on, or I gave everyone the highlighters inside your bag so that way you can highlight that section that you're confused on or something. Because when we meet with each other during teams, that is when you need to ask me the questions. So you need to do this assignment or do your assignments before you meet me on Teams. Because if you meet me on Teams and you didn't do the assignment, you don't have a clue of what you don't know because you didn't do anything. Okay? So let's go ahead and get started. Page 1. The definition of its science, it says here. Definition of science is the evidence to construct testable, and that's a key word there, has to be testable, explanations and predictions of natural phenomena as well as the knowledge generated through the process. We learn a lot through the process. Oh man, we did it the wrong way. Don't do it that way again. Next one, scientific notation. I know before you start thinking, oh, that's easy cheesy. Well, when we start getting into math equations where we're using some numbers really big and really small, you need to make sure that you can quickly put it into scientific notation into your calculator. Okay, so I will go over that in just a moment with you. Let me pull out my calculator, right? Hopefully you've already checked yours out so that way you can know how to put it in your calculator the correct way. If not, you're going to put it in the wrong way, come up with an answer, and you think you got it right, and it's really wrong. So it says here, scientific notation's use, it's because it's a quick way to write really, really big or really, really small numbers. All right? It says here that mathematicians are lazy, and because of that, they decided that by using the power of 10, they can create a shortcut or short version of a long number. Here's some of the rules for scientific notation. To be a proper scientific notation number, it must be written with at least one number to the left of the decimal, ranging between 1 through 9. Cannot be a 0. One more time. It cannot be a 0. I'm going to go ahead and put that on here. Cannot be a 0. All right. I like to write little extra parts inside my notes on the sides. It says here, and multiply by a power of 10, indicating the number of decimal places that the decimal needs to move. So it says here, let's go ahead and practice. Well, the first number is 2. And if you were in class with me, I would start picking on some of you to ask you. Because you know what? First thing is, you got in collegiate high school because y'all are some smart cookies. Okay? You passed the test, you got accepted, you're in. But how do you put the number 2 into scientific notation? It's not a really big number. It's not a really small number. It's a single digit number. Could that even be put into scientific notation? Okay, first thing, let's stop. Let's look over here. A scientific notation number is going to have only one number to the left of the decimal, right here. Then we have the decimal. Remaining significant figures are going to go behind it. Times 10 to this little x is going to be the power, right? The number of indications of how much you're going to move that decimal to the right or to the left. But this is a 2. Does the 2 have a decimal, first thing? And hopefully some of you are like, yeah, Miss Munson, it has a decimal. It's invisible behind the number 2. Okay, so my next question to you is that this little number up here, the exponent, is going to be the number of times that the decimal is going to move. Now, ask yourself, I mean, this is what I do. The way I'm talking to you here on the notes is the way I work through math problems in physics. Ask yourself, is that decimal going to move? Does it need to move? Is it going to move at all? 2.0 times 10 to the, is it going to move? No. 0 power. Miss Munson, I've never seen that. So, just because you've never seen something before doesn't mean that it's wrong or that it's impossible. I'm telling you, you're going to see some crazy stuff this year in physics with me, and you're going to think, man, I've never seen that before. I've never been told that. I'm telling you, it's okay. Some new stuff that we're going to start hitting. So, next one. Is there a decimal behind the 20 or in the 20? It is. It's behind it. Remember, for it to be put into correct scientific notation, one number to the left. So that means that this decimal must move. When it moves, it's going to move this direction one time. So it's going to be 2.0 times 10 to the how many times? 1 power. Next one. There is a decimal. It's invisible. And that's what some of us have problems with. Just because it's a number doesn't mean that there's not a decimal there. It is. You remember, it's invisible behind the last number. I'm going to move again this direction. How many times? 1, 2. So now it's 2.0 times 10 to the, how many times did I move it? I moved it 2 times. Okay. Next one. You've got one here to practice. I like to highlight the little sections here for you to do on your own. Okay. You're going to do that one on your own. Again, for every problem that you leave blank and for every word you leave blank, -1 point on your notes. And again, this is so easy cheesy of just writing the notes down. Why would you not do it? Let's keep going. If the number is less than the number 1, so it's a decimal, the exponent will be a negative. Okay? One more time, just to kind of help us out. If the number is less than 1, it will be a negative. So here's a few things I like to just jot down on my, again, on the side. I'm going to go ahead and put over here. Less than 1 equals negative exponent. I'm going to put a P. Okay. Now, this is not in scientific notation. It is in standard form. So I need to put it into scientific notation. What direction does the decimal need to go? Well, there needs to have one number to the left. And this decimal is to the right. This 0 doesn't count because it cannot be a 0. So the decimal has to move this direction. So when I have a number that is less than 1, to take it from standard notation or standard into scientific notation, I'm going to move the decimal this direction. How many times? 1. 2.0 times 10 to the 1. But wait a minute. When it's less than 1, it's going to have a negative exponent. Negative. Okay? Let's practice again. Here we go. 1, 2, 3, 4. Cannot stop there. 5. 2.0 times 10 to the 5th power. But wait a minute. -5. Okay, the decimal moves right. To put it into scientific notation. All right. And over here, you can see that all of our exponents are actually going to be positive numbers. I mean, we ignore the 0 because it never moved. So over here, if it's greater than 1, 2, 20, 200, okay, then in this case, then you're going to have a positive exponent, and we will move the decimal to the left. Okay? Again, there's another practice problem for you to do on your own. Keep going. Determine if the following numbers are written in scientific notation. All you're having to do is a yes or a no. That's it. Okay? So the first one, is the first one written in scientific notation? Well, it doesn't even have the times 10. So, no. That's pretty easy cheesy. I'm going to skip. I'm going to come over here. Is this written correctly? 23 times 10 to the 5th power. No. Why not? It's missing decimal. That's why. Let's go ahead. Let's look at this one. Is it written in scientific notation? No, not at all. It's missing the times 10 to the... Let's keep going. And plus, it has all those crazy other stuff. 10 times 10 to the 6th power. No, again. Same reason. It's missing that little decimal. Okay, how about the next one? Is that a yes or a no? 1 times 10 to the 0 power. I don't see a decimal. Is that a yes or a no? Again, if we were in class, I would sit here and I would start picking on y'all one by one. I don't pick on you to be mean. I pick on you because I want you to be confident in what you do know. Because you come to me as a smart cookie. I know you are. Okay? Now, 1 times 10 to the 0 power. First thing is, we've already said that that is acceptable. It's okay to write it that way. But the next thing is, I don't see a decimal there at all. Well, it's okay. What did I say up here? Just because you don't see a decimal doesn't mean that the decimal is not there. It's invisible. So this is actually has a decimal behind it. Yes, this is okay. That is acceptable. They may not be, 100% formally 1.0, but that is okay. That's correct. Yes. All right, so you got 2 to practice on your own. Turn the page. Now it says, first we were putting decimals, First we were putting numbers into scientific notation. Now we want to take numbers out of scientific notation. So in this case, it says if there is no decimal present, you're going to draw one behind the last digit in the number, right? It's invisible. Move the decimal the number of places indicated by the exponent. Remember, if it is a positive exponent, this is going to equal a big number. If it's a small exponent, it's going to equal a small, what did I say, small exponent? Man, if you were in class, you would be catching my crazy mistakes. But you're not in class, or you're not here with me, so now I have to catch my own mistakes. If it's a negative exponent, then it's going to be a small number, meaning that it's going to have a decimal. Okay? Let's go ahead and let's look at this, because we can add more here, and we're going to in just a moment. When we're taking it out of scientific notation, I can see that there is a decimal here. I have a positive exponent, so it's going to be a large number. A large number is going to be this direction. If I go to the left, and then I'm going to make it a small number. So 1, 2, 3, 4, 5, 2, 3, 4. All of these little bubbles are going to be zeros. 1, 2, 3. 1, 2, 3. So if it's a positive exponent, that's going to be a big number. When you take it out of scientific notation, now you are going to move the decimal place to the right. Move decimal to the right. And this one's the opposite. Move decimal to the left. Okay, well, let's look at that. We have one right here. -5. Well, that means I'm going to move it this direction to make it a small number. 1, 2, 3, 4, 5. The decimal now is over here because we moved it. All of those little bubbles are going to become zeros. 1, 2, 3, 4. So 1, 2, 3, 4. 2, 3, 4. Okay, here's a practice problem for you to do. Let's keep going. In the United States, it says here, we've got water. What is the number in scientific notation? There's a decimal behind. It's invisible. Move it. How many? 1, 2, 3, 4, 5, 6, 7. So 1.5 times 10 to the 7th power. That is a positive exponent because that's a big number, which is to us bigger than 1. Okay, you have another practice problem right here to do. Again, when you do your notes, hopefully you do your notes before you have the teams with me, or at least seen it, okay? Or the following teams meeting, then at that time you're to ask me, oh, wait a minute, Miss Munson, you gave us some practice problems, but this problem I was unsure. Can you go over it right now with us? And I can definitely do that, okay? Next one over here, which is correct? You're just multiple choice. 300 is going to look like 1, 2, 3.0 times 10 to the 2nd power, B. Okay, so again, there's more practice here. And let's keep going. SI units. I know you had a little video already over SI units. Let me stop real quick and let you know. If you were in my class and I had you, I would definitely let you know that giving me a number without an SI unit is like a horrible bad thing. That's just like, it's rude. It's disrespectful to the number. Okay. So here in physics or in science in general, oh my goodness. I mean, it doesn't matter what type of science, whether it's the medical field or whether we're talking about, I don't know, chemistry. If you don't have an SI unit behind it, I mean, horrible things can happen. Okay. So why are units important? Well, without units, numbers have no real value or meaning. Okay, so if I just have the number 2.3 and I told somebody that I ran 2.3, well, how far did I run? This number has no meaning. 2.3 meters, 2.3 miles, 2.3 feet. How far did I go? So units allow you to also check your answer. Remember, like I said, this is like almost another math class. And having your units when you're canceling out, doing your algebra, it really helps you to figure out if you're going on the right path. It says here, by knowing what type of units an answer or variable should have, then you can often determine the formula to solve that problem. If you haven't had a chance yet to look at the formula chart, and I'm just checking if I have one here. I don't have it right with me. But our formula chart has all of the equations that we are going to utilize first semester and second semester. If something comes up and we don't get to some of the problems, well, you know, something came up. But if not, then we're going to utilize those equations. Okay? Quite a bit of equations. First thing is, I don't think that you should have to memorize them. Okay? When you grow up and you get your real job, you can always look up the formulas, right? But how do you know which equation to use? Well, knowing which number you have with the correct SI unit can help guide you to the right equation, because some of the problems or equations, they look just the same. Okay? So it says here, for instance, if you know that speed has units in meters per second, and I give you a problem that asks you to find the speed of that car that traveled 246 meters, which is the distance, in 10 seconds, which is the time, how would you solve the problem? Well, this is the correct SI unit for speed, distance, and time. Not only that, but let's go back to your math class. You can see that this is distance, which is meters, because you know meters is distance, over seconds, which is time. Without having the formula chart in front of you, you can go ahead and solve this at 246 meters over 10 seconds, and you can solve this problem in meters per second. Okay? By knowing this SI unit that is for speed. Okay? Not always, it doesn't always work out like that, but it does a lot of the time, and so it's helpful. It said here, back in December the 11th, 1998. Ooh, long time ago, huh? They were sitting, it says here, they were supposed to orbit the planet like a satellite, and they were having this Martian climate, I guess orbiter or satellite, Mars climate orbiter, satellite it, which, you know, go around it. It says here, though, however, the orbiter software was designed in SI units of newtons, which we will definitely use newtons, for thrust. But the software on the ground that controlled it, the controls were using the empirical formulas of pound per force. Oh my gosh. This is SI units. Pounds is going to be the English system. They're not going to, they don't correlate. They don't, I mean, that's like dollars and pesos. They're not the same. Yes, they're both money. Yes, they're both SI units, but they're not the same SI unit. So if we've got this little Mars climate orbiter up going in outer space using this unit, and down here in the controls and NASA, they're using this unit, they are not going to have the same exact, they're not going to have the same number when they do their math. Okay, it says here that the orbiter was moving with too much force upon entry that the orbit of Mars, and it got too close to the planet, causing it to pass through the upper atmosphere and for that sucker to like burn up and destroy. Here's a problem. The problem is not, oh, okay, yeah, you made a mistake. Yeah, this sucker burned up and destroyed going into Mars. The real problem is, I mean, I'm not sure if you're going to keep your job afterwards because you just helped destroy $125 million. Are you insane? You really think that you're going to keep your job after that? I don't know. I kind of doubt it. Okay, so SI units are super important. Knowing that information, let's go ahead and let you know this. We only use the SI system here. We do not use units of the English system. That doesn't work. Like, we don't use Fahrenheit. We don't use pounds. We don't use miles. We don't use minutes. Those are bad. Those are like bad words. Now, do we sometimes use them? Yes. But we try to prefer to keep them within the SI system. And if we can, we're going to convert. It says here, the English system, believe it or not, it's actually still used. It's used mainly in the U.S. All right? Mainly in the U.S. Even though this system is the most commonly used system in everyday society, it is inconsistent and difficult to manipulate. For an example, gallons, miles, quarts, pounds. If I want to convert 4 gallons to however many quarts, I mean, how am I going to do that? The cool thing, though, with the SI system is that they have a common, that is common all over. So back in the 60s, the scientists all over in the medical field and science field agreed upon like one system to all use for their measurements. Not only that, but it's really easy to manipulate. In the SI system, if you're trying to do this kind of conversion, you're either going to add zeros and move the decimal over to the right, or you're going to take away and you're going to move the decimal to the left. That's it. That's all you're doing. You're moving the decimal. I need to know how many quarts are in a gallon. I've got 4 gallons. I'm sorry. I know some of you just came from chemistry class and you may have nailed dimensional analysis, but I hate that stuff. Okay? I love my SI system because all I have to do is move the decimal over. All right? So there are 7 base units. Only 7 base units. And you got those 7 base units in the other video that you watched. Okay? So scientists came up with 7 base units. Those 7 base units, all other units are derived from those 7 base units, which is pretty darn awesome. Okay? I was trying to see if I can have it right here. I don't have it in front of me. That's okay. Let's keep going. It says here the SI prefixes represents a scale of how big or how small the magnitude of that number is. So here are some of the 7 base units. Meter, kilograms, seconds, Kelvin, amps. We're missing 2. Candela and something else. My mind is, moles. Moles. So we're missing those 2 units. So all other units are derived from those 7 ones. So if I want to talk about a Newton is derived from here. Okay? I love this. Meter stands for distance. This is going to be the weight. I'm going to put /mass, right? We use the word weight every day. We fling that number around like that's nothing. But here in physics, the word weight and mass means 2 different things. If you say one word, you better mean that word because the other word means completely something else. Seconds, right, which is time. Kelvin, which is temp. And amperes, which is current. All right, let's keep going over here. Now, we're going to talk and we're going to go over, I told you because we've already went over it in those other sections of notes. King Henry drinks utterly delicious chocolate milk. Those are the ones that you need to have memorized in that order. Okay? Is there more? Heck yeah. They get bigger and they get